Hello and welcome back. Today we're going to talk about for loops and how for loops can make your life better. If you remember at the end of the last lesson, we had just had the turtle named Alex draw a square. And if we go back and look at this square drawing code, you'll notice something interesting about it. First we have Alex go forward by 50 and then turn left by 90. Then turn forward by 50, go left by 90, go forward by 50, go left by 90, go forward by 50, go left by 90. So we see that there's this pattern of forward, left, forward, left, forward, left. And even though it only repeats 4 times, there might be cases where we might want to repeat it by a whole lot more times. Whenever we see code like this, where we see a pattern that repeats itself, one thing that we want to learn how to use is a loop to replace all that duplicated code. And so that's what we're going to do today. We're going to use a for loop. Now the for loop has generally the format of something like this. It has the word for, of course, and then it has what we call the loop variable. So this loop variable can be any valid name, any variable name. And then after the loop variable, we are going to have some kind of a sequence. For example, a sequence of numbers or a sequence of names or something like that. And then that is followed by the colon. The colon character indicates to Python that whatever comes next should be indented, and we call this a block. So we can have a block of indented statements, statement 1, statement 2, and so on. As many statements as we want, as long as they are all equally indented to the same level here in our code editor. So that's the general format of a loop statement. Now, how does this loop statement actually work? Well, let's look at the following diagram to show us exactly how the flow of control for a loop statement works. So you might notice we're coming along here, along this line of execution. There may be some statements, and then we get to this decision, where we ask ourselves the question, have all the items in the sequence had their turn? Right, so we had that sequence list there in the for loop. If they have not all had their turn, then we follow the branch that says no, and we go to this box where we assign the next item in the sequence to our loop variable. All right, once we've assigned that loop variable, then we execute all the statements in the loop body. And remember, in the loop body, we could choose to make use of this loop variable and whatever value that loop variable happens to be referencing at the time. Once we've executed all the statements in the loop body, we follow this path back up and around, and we check again. Now have we moved to the next thing in the sequence? Have we used up all the items in the sequence? And if again the answer is no, we follow the no path. But if the answer is yes, then we follow the yes path, and we skip the assignment, and we skip the execution of the statements in the loop body, and we just go on with whatever happened to come after our for loop body. So that's kind of a general idea of how the loop unfolds. Let's look at how we can use the loop then to take this pattern, this repeated pattern of forwards and lefts, and turn that into a better turtle program. So here we have it. We have imported turtle, created a screen, made a turtle, and now you see we have right here for I in, and here's the sequence 0, 1, 2, and 3. Then we have indented, we have our two statements, alex.forward50 and alex.left90. And notice in this case we're not making any use of the I variable because we don't really have any need to it, but we have 1, 2, 3, 4 things in our sequence. So that means we're going to execute this body of the loop 4 times. So if we press run, there you go. You can see we made a 1, 2, 3, 4 lines and 4 right-hand turns. Right? Again, now there's nothing special about using 0, 1, 2, or 3. We could have had A, B, C, and D in the loop. And if we run this again, we'll see that we still draw a square. If we add e to this, of course, it doesn't really hurt us. It's just that we're going to draw a square that's a little bit too long. So let's get rid of that. All right, so let's do something a little bit more clever here. What if we said for color, we'll make a new loop variable in yellow, yellow, red, purple, and blue. All right, if we run it, again, we just get that same old boring square. But now let's do something more fun. Let's say alex.color, and we'll set the color to the value of the loop variable. So if we run this, the first line that we draw should be yellow because yellow is first in the sequence, and it will be and color will reference that first value. The next time through the loop, color will reference red, and it will color the line red. The third time through the loop, color will reference purple, and the last time through the loop, color will reference blue. So let's try that again. There you go. So we have a yellow line, a red line, a purple line, and a blue line. Okay, so that's a really neat way of visualizing how that loop variable is bound. We say the loop variable is bound to each number in the sequence. Now again, more typically we wouldn't care so much. We'll go back to our original example of 0, 1, 2, 3. And we start with 0 just because computer scientists typically start counting with 0. All right, if we do that, again, we're just going to get our old boring black square. Now this pattern of doing something so many times is so common that Python provides us a little shortcut for doing this. So instead of having to type in all these numbers every time, we can use a function called range. And we tell it how many times through the loop we want to go. So in effect, the range function that we insert here creates that same sequence of numbers 0, 1, 2, and 3. And so rather than us having to type out that sequence. Might not be a big deal for just a sequence of 4, but if we wanted to do something, say, 100 times or 1,000 times or even 1,000,000 times, we certainly wouldn't want to have to sit at the computer terminal and type out 0, 1, 2, 3, and so on all the way up to 1,000,000. Okay, so that's the for loop. We'll use that a lot because, as we'll see, these sorts of patterns are all over the place in our problem solving. And again, remember that computer scientist always looks for ways to be intelligently lazy. Thanks for listening.